Hi guys, welcome back to part 3 and I hope our final part of this assessment practice. So let's jump right on into number 8 so we can get finished. So number 8 says select all of the true statements. Now whenever it says all, that's pretty much an indicator that there's going to be more than one, or at least a possibility that it will have more than one. I'm going to select my pencil up here just so I can go ahead and be writing. Alright, so the first one says 33 has more than 2 factors. We already know that 1 and 33 are going to be the factors, but if we were unsure, we could come over here and we could list out the factors of 33. But I know that 33 has more than 2 factors because 11 times 3 equals 33. So I know that that is a true statement. Now, the next one says all of the factors of 34 are even numbers. And at first, that sounds like absolutely that's going to be true because 34 is an even number. But what is happening here? Let's look at this very first. If we look at these factor pairs for 34, the very first factor pair is 1 and 34. And we know that 1 is an odd number. So we know that that cannot be a true statement. So let's look at the next one. 35 has exactly 2 factors. We know that is not true because we know that 7 times 5 is 35, and so that already gives us more than the 2 factors. The next one says 3 is a factor of 36. Now, I already know that 12 times 3 is 36, so I know that is absolutely correct. But if you don't quite remember, one way that we can tell if a number is divisible by 3 is to find the sum of the digits. So for example, 3 plus 6 equals 9, right? And if the sum of the digits is divisible by 3, then the whole number is divisible by 3. Since 9 is divisible by 3, that means 36 is divisible by 3. Okay, so the next one says 37 is a prime number. So we could list out or create a factor tree, and we know 1 and 37. 2 is not a factor because 37 is an odd number. 3 is not a factor because 7 plus 3 is 10, and 10 is not divisible, by 3. And we could go through all the way up to 37 and see if there are any other factor pairs, but and we would find that 37 is indeed a prime number. There are no other factor pairs aside from 1 and 37. And the last one says that 38 is a composite number. We know that 38 automatically is a composite number because it ends in an even number. We know that any even number can be divisible by 2, which means that it has more than just one set of factors, right? So we could already know we can check that one as a true statement. So let's move on to number 9. It says Martika says factors and multiples are related. Use the equation 6 times 7 equals 42 to describe the relationship between factors and multiples. So I'm going to get a little text box up here and I'm going to drag it down so we can use it. I know that 6 and 7 are both factors of 42, right? I can multiply 6 times 7 to get 42 or 7 times 6 to get 42. I also know that because of that, 42 is a multiple of both 7 and 6. So that's kind of how they're related. All multiplication problems are going to be like this. Factors and multiples have a relationship. So 6 times 7, 6 and 7 are both going to be factors of 42 because you can multiply those together to equal 42. And then 42 is a multiple of both 6 and 7 because if we were to skip count or multiply, we would end up at 42. Okay. So let's move on to number 10. It says, which lists all the factors of 25 that are also prime? So for this one, we need to start by listing out all of the factors that we know of 25. So I already know that the first set of factors is 25 and 1. 2 is not a factor because it is an odd number. We cannot divide an odd number by 2 evenly. 3 is not a factor. 4 is not. 5 is. We have 5 and 5. Now, excuse me. These are going to be the only factors of 25. We have 1 times 25 and then 5 times 5. Okay. Now, it's not asking me, though, to list all of the factors. It's asking me which factors are also prime. Okay. So if I'm going to look here, 1 and 25, I know 1's a prime number, but 25 is not. We see right here that 25 has more than just 2 factors, so that cannot be it. 5. Is 5 a prime number? Yes, because the only factor pair that it would have would be 1 times 5. So that could be it right here. Oh my goodness gracious. This could be our answer here, but let's check. 1, 10, and 25. 10 is not even a factor of 25, so we know that can't be it. Or letter D says 5 and 25, and like we already said, 25 is not prime. So the correct answer would be B. The only prime factor of 25 is 5. So let's move on to number 11. Carter lives on a street where all of the house numbers are multiples of 6. Name 2 possible house numbers between 70 and 80 and explain. So what I'm going to do, just to help me, is I'm going to list out the multiples of 6, but I'm going to start with 60. So, excuse me. So I'll have 60, 66. Hang on. So what I did was I just listed out the multiples of 6, but instead of starting with 6, I started at 60 just so I could see the numbers between 70 and 80. So if I have these multiples listed right here, there are only 2 multiples that land within the criteria of being between 70 and 80. Those 2 numbers would be 72 and 78. Okay. And we know that these would be multiples of 6 because we can divide and we would not have any kind of remainder with these numbers, right? So number 12. Write the factors of 30 that are also prime numbers. Again, this goes back to this one like number 10, but we're going to start out by just writing the fact. Oh my goodness gracious, Miss Barton. We are going to start out by simply writing the factors of, good gracious, guys, I'm struggling. Writing the factors of 30. Here we go. So I know I have 1 and 30. I know that 2 is a factor because 30 is an even number. So 2 and 15. I know 3 and 10. Excuse me. 4 is not a factor, but I do know that 5 is a factor. 5 times 6. And then I can actually stop here because my next factor would be 6. And that means that we are done listing out all of the factors. Now, let's look and let's decide which of these factors is also a prime number. So I'm going to change the color. All right, so I know that 1 is a prime number because the only factors are 1 in itself. And then 2 is also a prime number because 2 times 1 is the only factor pair. 3 is also a prime number. And 5 are all prime numbers because the only factors that these numbers have are 1 and itself. 6, 10, 15, and 30 all have additional factor pairs, which makes them composite. So if I were going to list out my answer for number 12, I would say 1, 2, 3, and 5 are the prime numbers that are factors of 30. Okay, last one, and we will be all finished with this assessment review. So this Javier says that all odd numbers greater than 2 and less than 20 are prime. Find an odd number greater than 2 and less than 20 that is not prime. Explain why the number is not prime. So first of all, what I want to do is I want to list out all of the odd numbers between 2 and 20 just so I can visualize what it's asking. So I know we have 3, 5, 7, 9, 11, 13, 15, 17, and 19. Okay, so Javier thinks that all of these odd numbers have to be prime. So what we need to do is find one that is not prime so we can explain why. So I'm going to go through and kind of decide where I need to stop. We already established that 3 and 5 are prime numbers, so I can go ahead and mark those out. 7 is a prime number. The only factor pairs that 7 have are going to be 1 in itself. But when I get to 9, I know that 9 has more than just 1 and itself. Okay, so if I were going to list out the factors of 9, I would have 1 and 9, and then I would have 3 and 3. So that tells me that 9 is not a prime number. So for my explanation, what I'm going to do, is drag my thing down here, and we're going to say 9 is a composite number because it has more than 2 factors. Is there another number, another odd number between 2 and 20 that is also a composite number? Yeah, look right here at 15. We have 15. We know that we can do 3 times 5, and that would make it composite. But it did not ask for us to find all of the numbers. It just asked us for one number that is not prime. Okay, so I hope that this helps you guys. If you have any questions, feel free to reach out. I'm happy to help, and I cannot wait to see you guys next time. See you soon.